All right, morning guys. Welcome to Physics 101 today. Since it's the first class, I'd like to introduce myself. My name is Lei Chen, and I'm going to be your TA for the rest of the semester. So today we're going to talk about gravitational force. Okay. Okay, so I think most of you have heard a story about gravitational force, where it is from,
Newton.
how it was born. So the story was like this. Back to the day, one day when Sir Isaac Newton was tired, he was trying to taking a break, and in a hot summer like this, he just find an apple tree and sit underneath it, and then he was enjoying himself in a cool air and under a shade, and then all of a sudden, there's an apple fall down from the tree and right onto his hat. Bang! There it goes. You have the gravitational force and gravity theory. So, funny thing, almost every interesting or great theory comes from a bang, like the Big Bang theory, right? Okay, let's back to the business. So, what is a gravitational force, or what is gravity? So gravity generally describes the tendency between two objects that are trying to attract each other. Okay, so the gravitational force will be the force between these two objects, or the force of each one that applied to the other one. Okay, so people find out that it's universal in the Earth or in the space between every object, like me and the chair. There is a gravitational force. You may not believe it, and you don't think you experience that, but we actually experience gravitational force every day. That's why we stand on the Earth right now, right? So that is gravitational force. Okay, and today I would also like to talk about what it is related to, what quantity it is related to. Okay, so give you another example. We all know different things on the Earth weigh differently, like all of us, we weigh differently. Actually, weight is another way to say the gravitational force between us and the Earth, or between a thing and the Earth. That is what we call weight, another way to say the gravitational force. So why we weigh differently on the Earth? That is because we have different mass, right? We have different mass, so we weigh differently. So the gravitational force must have something to do with the mass, right? So just the mass of one thing or the mass of both, because the gravitational force is an interaction between two objects. So let's think about another scenario. We stand on the Earth, we stand like this, right? But you all pretty much seen the astronaut in the space, or when they walking on the moon, they kind of do that, right? They kind of jump, because they kind of floating around, right? Why is that? That is because the mass of the moon is so much less than the mass of the Earth. So you don't experience a lot of gravity, or the force between you and the moon than you and the Earth. So it must have something to do with the mass of both objects, all right? Okay, then what else? It has something to do with the distance too. The distance between the two objects. So I should draw this earlier. So two objects, gravitational force in between, and distance is also important. Again, same example of the astronaut. When they do the spacewalk outside the shuttle, they have to attach themselves to the space shuttle so they won't flow away, right? Why is that? They still experience gravitational force back to the Earth, although it's far, far away. So because the distance is so far, they don't experience so much gravity than we do right now by standing on the Earth so close. So that's why they experience so much less. And then it means the gravitational force mass has something to do with the distance. Okay, and today we're just gonna talk about the relationship qualitatively. Next time we're gonna do experiment for each group, and then you're gonna use that to find out the mathematical form of this equation. Okay, all right. That's pretty much what I'm gonna talk about today. And is there any questions? No. Ready. Thank you very much.